Hey guys, and welcome to your first AP Chemistry video for Mr. Ponto's class for Plainfield East High School. We will be going through part of the first chapter of your Zumdahl textbook, Chapter 1, Chemical Foundations. This should just be a review for regular chem or honors chem, doesn't matter which class you had. This should mostly be review material that you should have a pretty good grasp on already. So the first thing we want to talk about is our units of measurement. And in a science class, we always want to make sure that our numbers have units attached to it. That's the most important thing to keep in mind here. Now, these units could be grams, they could be moles, they could be anything. As long as we have a number attached to them, that is all that we need to make sure we do. Again, you see examples down there at the bottom, something like 20 grams or 6.63 times 10 to the negative 34th joule seconds. Now don't just go around attaching random units to random numbers. Make sure that our units are properly attached to the proper numbers. Up here at the top, we see that we have something called SI units. And SI units are very important. It stands for Standard International. And what Standard International units do for us, it translates all units to be the same. So scientists in the United States can talk to a scientist in another part of the world, in Europe or in Asia, and they're all going to have the same units attached to the same numbers. So they can talk about their research and know that all of their numbers mean the same thing without having to change kilometers to miles or miles per hour to kilometers per hour. All of their numbers are going to have the same units because they use the same standard international units for all scientists around the world. The most important ones that we will be using are the first four: mass, length, time, and temperature, and the last one, the amount of substance, which is what we call moles. I think we're all pretty familiar with the first four. We just need to make sure that we remember what a mole is, and we'll talk a little bit more about that later. Couple other things to keep in mind here are prefixes that we can attach to numbers. The ones in blue are really our most important ones that we will be using most frequently, and specifically probably kilo, centi, milli, and micro would be the most used of those. Those are our most common prefixes, and we need to remember that these prefixes tell us different things about numbers. If we have a kilometer, that means we have 1,000 meters. Or if we have a millimeter, that means, I'm sorry, not a millimeter. If we have a centimeter, that means we have 1/100th or 210 to the negative second meters. So we attach this to our base unit to change the meaning of that base unit, to change how much of that number we have. The next thing that we want to talk about would be something called uncertainty in measurement. And this might not have been very important in your last chemistry class. It's going to be incredibly important for AP chemistry. We always need to make sure that when we are taking a measurement that we have one estimated digit. And that one estimated digit is really important because when you take this together with the rest of the digits, we get something called significant figures. And this estimated digit will change. Sometimes it'll be one spot after the decimal place. Sometimes there won't be a decimal place. Sometimes it might be 3 spots after the decimal place. But it depends on the unit or the device that we are using to measure our different things in lab. So if we look here at something called a burette, right? The first thing that we want to notice is that as we go down the burette, our numbers are increasing. So don't make the mistake of thinking that this measurement right over here, because the measurement is below 20, it's not 19. It's not 19 point something. It's actually going to be 20 point something. Excuse me. Because our numbers are increasing as we go down the burette. So if we were to read this, remember we always want to read at the meniscus, right at the lowest part there of our curve. And when we do that, we should get about 20.15. Now remember, we want one estimated digit. So the 3 that are not estimated, right? If we look at the certain digits, that's going to be these first 3 here, 20.1. Because as we go down, this is 0.1 and 0.2 and 0.3 and so on. And if we're in between there, we don't know exactly, there's no line to tell us exactly how much between those two lines we are, right? There's no way to measure that exactly. So that's our estimated part of our number. So the uncertain part, the estimated digit, would be our 5 at the end. Now you might look at that and say, no, I think it was 20.14. That's acceptable because this last digit here is estimated. You might say it's 20.16. That's okay as well because that last digit is estimated. It might look a little bit different to different people, and there's nothing wrong with that as long as we have that one estimated digit. Never leave this off, otherwise that will be considered incorrect. Next thing that we want to talk about would be precision and accuracy. Right? Precision is how close or how repeatable your numbers are. It doesn't have anything to do with how correct your numbers are. If you look here at these darts, they are nowhere near the bullseye. So they're not necessarily correct. They're not in the right spot, but they are all very close to each other. So we would call that precise because those darts were repeated in the same spot over and over. Now it was repeated wrong, but that's okay. They were all close together, so they are still what we call precise. Accurate would be how close you are to the bullseye, to the center of your target. And if you look here, right, these darts are all grouped very close to the bullseye. They're also grouped very close to each other. So that means this would be precise and accurate because they're close to each other and they're close to what they're supposed to be close to. They're close to the right value. Over here, the darts are not close to each other. On the left, they are also not close to the bullseye, so this would be neither precise or accurate. Then we look down here and we have two different sources of error. We've got random error and we have systematic error. Random error would be like closing your eyes and throwing darts at the bullseye. You don't know where you're going to miss because you can't see your target. You might miss to the left, to the right, up, down. Maybe you hit the bullseye perfectly, but it's going to be inconsistent, and there's no way of knowing how that inconsistency will occur. It's not always going to be in one direction because your eyes are closed. You can throw it all over the place. Systematic error, however, is going to be a measurement that is wrong, kind of like these pink dots or these pink darts up here. They are incorrect. They're not close to the bullseye, but they are all close together. They're inconsistent, all in the same direction, all to the top right of the target. So that would be a systematic error, a miss that is always in the same direction. Now we need to talk about significant figures, which we briefly mentioned before. And this is one of the most important things that we will carry throughout the year, that will be on the AP exam. And unfortunately, you can't get away from them, and you really need to know these well. Your first rule is really easy, non-zero. So anything that is not a zero is significant. So all of these numbers here, the 3, 4, 5, 6, 3,456, 4 numbers, 4 significant figures because they're not zeros. After that, we need to take a look at zeros, and this is where it can get a little bit tricky. There's 3 different rules for zeros, and the first one would be called leading zeros. Zeros that come in front of your non-zero numbers, and these are not significant. They do not count. All right, never. Leading zeros will never count as significant. So the only thing that is significant in this number would be the 4 and the 8, so there are 2 significant figures in this number. Doesn't matter how many zeros there are. If they are leading zeros, if they come in front of your number, then they are going to be not significant. And so this example right here would have 1 sig fig, or 1 significant figure, because those zeros do not count. The second type of zeros are going to be captive zeros. I like to call them sandwich zeros because they are in between 2 non-zero numbers. So this 0 here is in between the 6 and the 7. These are always going to be significant. So this one would count, the 0 would count, so we'd have 1, 2, 3, 4 significant figures for this number. You can have more than 1 sandwich 0 or more than 1 captive 0. All of these zeros here are sandwiched in between the 6 and the 1, so they would be significant. So we would count them, and we would have 1, 2, 3, 4, 5, 6, 7 sig figs in this case. Our last type of zero is going to be something called trailing zeros, the zeros that come at the end of a number. Now this all has to do with the decimal point. If there is a decimal point, like we have in our first example, then with that decimal point, that means, sorry about that, that the zeros are going to be significant at the end. So we would have 1, 2, 3, 4 sig figs here because we do have a decimal point. If we don't have a decimal point, like in our second example, there is no decimal point at the end of the 150, then the 0 is not significant. So only the 1 and the 5 are going to count as significant. So there would only be 2 sig figs in this number. The final rule for sig figs would be something called exact numbers. Exact numbers would be something like 1 inch is equal to 2.54 centimeters. We know this exactly. We can measure that with a ruler exactly. And because it's an exact number, they have an infinite number of sig figs, so we don't even count. We just kind of ignore these numbers. Anytime you have an exact number, it does not play into your significant figures. You can just ignore it. A few other examples would be like counting 9 pencils. You know that there are 9 pencils on the table because you counted it. So you don't say there's one significant figure, there's an infinite number of significant figures. Now let's move on to our calculations. If we have to multiply, and then we have to take into account our significant figures after our multiplication, we need to know the least precise measurement. So the least precise measurement of this first calculation here, well, we've got a number here with 1, 2, 3, 4 sig figs because all of them are non-zeros, and so they all count as significant figures. Then we look at our second number here, and our second number would only have 2 significant figures. The 2 significant figures is our least precise number. So that means when we get our answer, we have to round it to 2 sig figs. So if you plug it into your calculator, this is what you would get here. This would not be the correct answer in AP Chemistry. This would have a point taken off for it because you did not round to the correct number of significant digits. And so what you need to do is take your answer. Because our least precise number was 2 significant figures, we would round that number to 7.4. Now this number has 2 sig figs, and we would be correct in our answer at 7.4. This is with multiplication or division. With adding and subtracting, it's going to be a little bit different. When you add or subtract, you use the same number of decimal places as the least precise measurement in the calculation. So if we take a look here, we have 23.445 plus 7.83. And what we need to pay attention to here is the number of decimal places that each number goes to. Because this only goes to the 100th spot, it only goes 1 place past your 2 places past your decimal point, whereas this number goes 3 spots past. This is where we will limit our significant figure. That is where we will stop our answer. So if you add these two together on a calculator, you get 31.275. Now we know that this 3 here is the 100th spot. That limits where our sig figs can go to. So we have to stop at the 7 here. And so our 5 is going to round that number up, and our corrected answer would be 31.28. So this number would have 4 significant figures, and that would be our proper answer. Notice how it has 4 sig figs, and our least precise only had 3 sig figs. Remember, it's only multiplication and division where it's the least number of significant figures. So you don't want to round this to 3 sig figs. You want to make sure you go to the 100th place with your answer. When we go to our 100th place with our 8, that gives us our 4 significant figures. Just a couple more slides here. Let's make sure we understand our sig fig calculations here. If we have 2 graduated cylinders, both of these are different. How would we describe the total volume? So if we were to mix these two together and add up their volume, so if we measured this one and we measured this one, then we mix them together, what would our total volume be? So we need to add these numbers together. The first number that we're going to read here, we need to read from the bottom of the meniscus, all right? And from the bottom of the meniscus, we would see that this number would be about 2.2, 2.4, 2.6, 2.81 is what I would read for this one. So we would have, whoops, let me get my pen back here. Pointer options, pen. Okay, so we would have 2.81 plus whatever we would have over here. It's going to be 0.2, 0.22, 0.24, 0.26, 0.281. So I'm going to add 0.281. Remember, we need our estimated digit there at the end, and our 1 would be the estimated digit. 0.28 is this line right here. Go away, please. Thank you. 0.28 is right there, or just above that. And so then we need to estimate 0.281, the 1 right after that. If we add those numbers together, I don't have a calculator on me right now, so let's see if we can do a little bit of mental math here. This comes out to about 3 point, if we're focusing, doing our mental math, 3.091, I believe. Now, this would not be our correct answer because we need to add. If we're adding, we need to take into account the least number of places past the decimal point, right? This one only goes 2 places past the decimal point, so we need to round this 2 places past the decimal point, and we would have our answer of 3.09. What limits the precision here of the total volume? It's going to be this graduated cylinder. It is less precise than our graduated cylinder on the right. The very last thing that we have to talk about today would be dimensional analysis. This slide is just a fancy way of telling you that it's just converting one unit to another unit with the appropriate factors, with the appropriate conversion numbers. So let's just jump straight into an example. You should remember this from math class, and so if we have something like 4.50 pounds and we want to convert this into grams, then we need to take our 4.50 pounds, we need to multiply by our conversion factor here. So we are going from pounds into kilograms, right? We can't go straight into grams because we don't know how many pounds are in a gram. So we go from pounds to kilograms, and notice that our units will cancel out here, our pounds, because this would be over 1. So pounds on top, pounds on bottom, this is going to cancel out. Then our next slide, oh hey, look, it showed that for us as well. Our next conversion is going to be from kilograms into grams, and that is given to us here, which this is one you should know. There are 1,000 grams in 1 kilogram. And so again, our grams are going to cancel out, and that's going to leave us with 2.04 times 10 to the third grams as our answer. Notice these would all be exact numbers, so these numbers here do not count for significant figures. So in this case, you only have to worry about your first number, 3 significant figures here, 3 sig figs. And so our answer should also have, and it does, 3 sig figs. And so that matches up as well. We also have our unit attached, so that is a perfect answer for our first problem. This next one you're going to try on your own. It's a little bit tricky. You want to convert meters per second into miles per hour. And we'll talk about this first thing in class tomorrow. So I'm not going to give you any help. Try it out, and I will ask someone to do this on the board if they can figure it out at the start of class tomorrow. Thanks for listening. Hopefully the videos are usually a little bit shorter than this, but we had a lot to go through for our first video. I will assign another one probably the next night for homework. So thank you again for listening, and I will see you guys in class tomorrow.